Hello, today we will talk about measuring current. What is current? Current is the flow of electrons through a conductor. The water analogy is that current is like the water flowing through a hose. Current is measured in amperes and show from this illustration 1 ampere is a large number of electrons flowing past a spot in the conductor in 1 second. As you can see in this illustration, 1 ampere equals that number of electrons. I won't read it in 1 second. And current in normal electronics can be in the range of hundreds of amps to millions of an amp, micros to billionth of an amps, nanos. You will generally work with tens of amps down to micros of amps in the typical electronic devices. You won't deal with higher values than 10 amps since they require a special device for measuring them, and they are mainly used in factories, not in everyday electronics or in circuits or common circuits. So now let's look at current measurement. There is greatest potential for meter damage when measuring current than any other function. Just as in voltage, there is two kinds of current associated with the voltage, AC and DC. This meter will only measure DC. More expensive meter will measure both currents. To measure current, the volt ohm meter must be inserted into the circuit so that the current flows through the meter. There is no way that you place the positive and negative probes and say, yay, I just measured current. This won't work like voltage. You must place it in the circuit, not on the circuit. So we must again mention safety during these measurements, and we must spend some time to amplify your knowledge in how to use the volt ohm meter to measure currents the right way. And we mention that the current must flow through the meter as opposed to measuring voltage when it was only necessary to sample the voltage surrounding the source. Generally, to have the current flow through the volt ohm meter, an existing circuit must be broken, unsoldered, and the meter probes connected to either side of the break. The volt ohm meter then becomes part of the path through which the current must flow. There are two current ranges, high up to 10 amps and low 200 milliamps or 0.2 amps and below. Internal fuses provide some meter protection for over current situation. Because there is such a wide range of current scales, there are two physical probes jacks for the two ranges. This allows for better protection, a hard fuse to handle up to 10 amps of current, and a more fragile fuse to protect the sensitive circuits needed to measure small currents. Now we will see these two ranges in the meter, but we must read that caution. There must be some resistance in the circuit or the current flow through the circuit will be the maximum the source will produce, and this current level could damage the volt ohm meter. So you must make sure that there is some resistance. You must not connect the volt ohm meter to measure current directly and place it inside the circuit. In other words, do not connect the volt ohm meter probes directly across the battery poles in the current measurement function. This is useless and it will damage your volt ohm meter. So with no resistance in the circuit, the voltage source will provide the full current available to the circuit. There is essential no resistance in the volt ohm meter probe lines. Therefore, if the probes are connected directly across the battery poles, the full current in the battery will flow through the volt ohm meter and probably blows the fuse. So we must make sure that there is some kind of resistance in that circuit. If there isn't, you must place a resistance inside that circuit. Hello, now let's look at measuring current in practical. We will be using some concepts during the current measurement exercise that will be covered in more details later. So please be patient, it will all come together in the end. In the following exercise, you will use various resistors to limit the current flow in a sample circuit. This is the breadboard or the protoboard. This is simply a board that you use to test electronic circuits. You can place your elements here and connect power. Then you can see how the circuit function before building a more permanent prototype. Proto stands for prototyping. You need to understand the difference between the interconnected holes here. As you can see, each 5 holes here are connected together horizontally, not vertically. And the same is here. These 5 are connected together. So you can consider them as one pin. The same goes here and here. While these two, blue and red, are called power rails. So from here to this pin, this is the negative power rail, and from here to here, this is the positive power rail. So if we place, let's say 9 volt and ground, this is the ground wire and this is the 9 volt wire. If we connect them here, then all of these pins will get 9 volt. You can connect a LED to these pins, and you can connect a wire and take power from these pins, while the other pins here in that vertical line are connected to ground. So this is for connected other circuit components here and here to power and ground, and it's a really useful board. As you can see, again, the vertical rows in the center that have red and blue lines next to them are connected together. The holes in the red row are connected together. The holes in the blue row are connected together. The board, as shown, are configured to have these rows as power sources, red for positive and blue for ground or negative. There are 4 black there are 4 banks of horizontal rows. As you can see here, this is one bank, second bank, third and fourth bank. They are connected together. The horizontal rows are where the components will be interconnected, and the vertical center row will be connected to the circuit power to provide the other circuit element with power. Now let's look at measuring current basic circuit. As you can see here, this is a resistor that we will use to limit current so we won't damage our digital multimeter, and this is a battery, a 9 volt battery in that case, and this is our volt ohm meter that is connected through the circuit. As you can see here, this is the positive terminal. It's not connected directly to the resistor. We cut the circuit and place the volt ohm meter right in the middle so that the current will pass through the volt ohm meter. Now let's look at this circuit in practice. First, current measurement. Set up the circuit using 100 ohm resistor, brown, black, brown. You need to have 100 ohm resistor like this one, as you can see. Now connect a wire to the positive power source and connect another wire to the tab end of the resistor. As you can see, this is the positive power source and this is the negative power source. We must connect the first resistor wire to the positive, and we must connect the other wire to the other terminal of the resistor to a wire, then to the black terminal of the volt ohm meter. We need to set the volt ohm meter current scale to 200 milliamp, as you can see here, 200 milliamp, and we need to place the red probe in the right place here in the milliamp connector, not in the 10 amp connector. Without connecting the battery, practice touching the volt ohmmeter probes to the exposed wire ends. You need to take some time to understand this example before going further. Now let's connect our battery and measure the current with the volt ohm meter set to the 200 milliamp current scale. Touch the black lead to the wire hooked to the high side of the resistor. Then touch the red lead to the lead coming from the positive side of the battery. Know the volt ohm reader. It will give you 89.2, and this is in milliamps, so the current flowing through that resistor is 89.2. Now you need to understand that we got the reading in milliamps, so if we want it in amps, it will be 0.0892 amps. You must multiply that number by or divide it by 1000 to get that amp reading. Now if we look here, as you can see, if we reverse the volt ohm meter leads, we can note that the reading became negative 88.0. This is obvious, since we reversed the two probes, we will get a negative reading. Now let's return to the volt ohm reads, return volt ohm probes to their original position. The red is connected to the battery. Change the volt ohm current ranges down and know the display reading. What is the best range for measuring the current from a 9 volt source through a 100 ohm resistor? You will notice that when you reach the 20 milliamp range, it will give you 1, and we did explain what 1 mean. It means out of range, and you mischoose the right range, while in 200 milliamp range it gave 89.2. Now let's look and wire the circuit with a 1 kilo ohm resistor, brown, black, red. This is that resistor, and measure current with 200 milliamp range. Let's see the results. What is the best range to measure the current through a 1 kilo resistor? As you can see, in 200 milliamp range, it gave us a 0 on the left, which means that we can get a more precious reading. So if we switch it to 20 milliamp, it will give us 9.4 milliamp, and if we switch to 2000 microamp, it will give us out of range. So this is the best, let's say the best range for measuring. You must test that for sure to get a clue how much current will pass and what is the best highest resolution scale. Now as you can see here, let's wire that circuit with a 10 kilo ohm resistor, brown, black, orange. These are the three colors. Let's measure the current with 2000 micro amp range. As you can see, it gave us 955 micro amp. These are different lab results. If we did another measurement, as you can see, the best range for the 10 kilo ohm resistor is the 2000 microamp, since if we choose the 200 microamp, it will give us out of range. Now another example. Let's say that this is our last example in this exercise using 100 kilo ohm resistor. Let's start at 200 milliamp scale and read the current using each of the four ranges and record the result. This will be a good opportunity to again go over converting currents from amps to milliamps to microamps, and also illustrate how to determine the best range for the current being measured. As you can see, in case of 100 kilo ohm resistor, brown, black, yellow, if we started with a 2000 milliamp, it will give us 0.09, and going further it will give us a higher resolution depending on the range. That's it for the practical part for measuring current. Next we will be measuring resistance. Hello and welcome to this new lesson in which I will teach you how to measure current. Measuring current is a little bit harder than measuring voltage because there is two ranges, the milliampere and the ampere range. So you don't want to confuse these two because this might damage your digital multimeter. So when you are measuring, if you are measuring small amp, use this one. If you are not sure, use this one because it can measure up to 10 amp. But if you measure higher than 10 amp, you shouldn't use this one. You should buy a watch that has such specifications. Now, in order to measure current, you need to move the dial here. As you can see, we have from 20 milliamp to 10 amp AC and from 20 milliamp to 10 amp DC. So let's start by stating how to measure current. In order to measure current in a circuit, you need to do a short. So you need to cut the circuit. Let's say that we have a 9-volt battery, the positive terminal, and we have a LED, a resistor, and a LED, and a ground. This LED will turn on. If we want to measure how much current is withdrawn in this circuit, we need to break this circuit. So now it will become like this. And this. These are the two probes of the digital multimeter. We must add them in series with the circuit so that we can measure the current. Now, the same thing apply to, as you can see, this is a DC volt. The same thing apply for AC. If you want to measure a current that goes through, let's say, a 200 to 20 volt AC plug. Let's say that this is the AC plug. You need to go to the digital multimeter. Then let's say that this is a light bulb. This is the line and this is the neutral. The neutral will be connected directly while the line must go through the digital multimeter using these two probes in order to measure this amp that the lamp consumes. I will show you how to do it for the DC circuit, and the same thing applies for the AC circuit. You need to cut the circuit, cut the wire, and let it pass through the digital multimeter. Then you can simply see the results on the LCD display of the watch. Now let's do this in action. I want to measure DC volt, so I must move while the digital multimeter is turned off. Let's move to the DC range. Okay, I will measure small amp, so I will go to the DC 200 milliamp. Now I will place the probes, the COM on the COM, and this one on the milliamp because I know I will be measuring on the milliamp range. Let's turn on the display, and I will take the measurement for a very simple circuit. I have it here. As you can see, we have a LED and a resistor, as I drew earlier. In order for this to turn on, you must connect it like this. The positive terminal to the resistor and the negative terminal of the LED to the ground, and as you can see, it's on. I need to cut this circuit, so I will do the same. I will connect the negative terminal to this, but the positive terminal I will connect it through this device or through the probes of this digital multimeter. So let me just hook it up here. As you can see, now I have this probe and this probe. I will connect the negative to the battery and connect the other probe to the digital multimeter.